Hello, everyone. Today, our group will present about application usage on mobile devices. So first, how we collect our data. Our data collection method is a Google Form survey. For our probability and statistic project on mobile application usage, we utilize Google Form as the primary tool for the data collection. Here's how we structured our survey and collect the data. First, our survey design. The survey consisted of 14 questions covering various aspects of mobile application usage, including spending habits, usage patterns, academic performance, and personal perceptions. The questions were designed to gather both quantitative and qualitative data to provide a comprehensive understanding of the participants' mobile behaviors. The distribution. We shared the survey link through multiple channels such as social media platforms, email, and direct communication. Anonymity and confidentiality. The participants were assured the anonymity and the confidentiality of their responses to encourage honest feedback. We enabled the anonymous response option in Google Forms to protect the participants' privacy. Next, our data validation and quality assurance. Validation rules were implemented within the survey to ensure data accuracy and consistency. Next, descriptive statistic and histograms. Here is a pie chart of the gender of our survey from our survey. 67.4% of our participants were female, 30.4% of our participants were male, and the other chose not to disclose. We have collected data from two forms, one in Thai and one in English. The Thai form received a total of 100 responses, while the English form received up to 29 responses. Here is our histogram on the frequency of how hard it is not to use your mobile phone throughout the day. And these are our values.
On the correlation part, there are four graphs that we want to show you guys more about the mobile phone behavior of the people. First, the correlation graph. This graph shows us the maximum amount of the money that people are willing to pay between their non-education and education applications. As you can see on the graph, this is clearly that this is a positive correlation. So that suggests that the individuals who spend more money on an education app are likely to spend more on education apps as well. But the relationship is not extremely strong. And the next graph, this pair is shown about the average hours of using social media app per day of the people between during the non-exam period and exam period. And you can see as a graph that as positive correlation suggests, this provides that who spend more time on social media app during the non-exam period are likely to spend more time on social media app during the exam period as well. And the third graph is showing about the average hour that people spending on the educational app per day between exam period and non-exam period. This graph shows us the positive correlation indicate that there is some association between the average hour of using education app per day during the non-exam period and the average hours during the exam period. But other factors may also influence their usage pattern during these two periods. And the fourth graph is show us the average hour that people live during the exam period and non-exam period. This is provide that the negative correlation. It shows us that there is some association between the average hour of sleep per day that during non-exam period and the average hour during the exam period, in a way in which people tend to get more sleep during the non-exam period than the exam period. On the nominal part, these two bar graphs show us the people, what app that people spend the most with between the non-exam period and exam period during. First graph, the non-exam period, that show us the most of people use their social media app the most, like Instagram, Facebook, TikTok, and Facebook. By the way, during the exam period, the most of people use the YouTube. This is assumed that the most of people use the YouTube app to education and less more about the social media app.
For the education apps that people spend it most time with during the non-exam and during the exam test, both has the same output that most people use good notes for their education apps. Yeah. For our good net of it test, the first question that we pick is what's your last semester GPA? For the hypothesis, we hypothesize that the distribution of GPA is the normal distribution graph, and for the null hypothesis, we assume that the distribution of GPA does not follow the normal distribution. After we compute and look through the chi-square table, we conclude that the GPA data is not follow the normal distribution with the mean 3.37 and SD 0.47. And for the next unit of the test, we choose the question that had a scale 1 to 5 of how hard is it to not using your mobile phone throughout the day. For the hypothesis, we hypothesize that the distribution of how hard not using mobile phone data is uniformly distributed. And for the null hypothesis, we hypothesize that the distribution of how hard not using mobile phone does not follow the uniformly distribution. And the result is the distribution of how hard not using mobile phone data is also not going through the uniformly distributed. So we rejected the hypothesis. For the last question of Good of the test, we picked the how much do you think your mobile behavior impact your GPA in a negative way. For the hypothesis, we think that the distribution of mobile behavior impacting GPA uniformly distributed. The parameter is min equal to 1 and max equal to 5. For the null hypothesis, we assume that the distribution of mobile behavior impacting GPA is not uniformly distributed. For the result, we conclude that the distribution of how much do you think your mobile behavior impact your GPA is not uniformly distributed with the parameters min equal 1 and max equal 5. So this one, we also rejected the hypothesis.
For the hypothesis test, we pick the same question as good net of fit test. So the first question, what is your last semester GPA? The test hypothesis only claim that average GPA is greater than 3.00. The standard deviation of GPA is 0.4744 is given. Assume that GPA is normally distributed. So the null hypothesis is the mean is less than or equal to 3.3751. Hypothesis said the mean is greater than 3.3751. We choose a significant level equal to 0.1. So we got it. So we got the c-score equal to minus 1.2816, and the test statistic is equal to 8.9499. So after the computation, we can conclude that the average GPA is significantly greater than 3.00 based on the sample data collected. For the next question, how hard is it to not use your mobile phone throughout the day? This is a hard question. Test hypothesis only claim that how hard is it not to use your mobile phone throughout the day is less than 3.00. The standard deviation of the question is 1.1696 is given. Assume that the question is uniformly distributed. So the null hypothesis say mean is less than or equal to 3.00, and the alternative hypothesis said mean is greater than 3.0. Again, we use significant level at 3 there. Again, we use significant level equal to 0.1, and the c-score is the same, minus 1.2816. After computed, the test statistic is 5.4754. So we can conclude that on the average, people find it harder to not use their mobile phone throughout the day based on the sample data collected. And the last question, how much do you think your mobile behavior impacts your GPA in a negative way? The test hypothesis only claim that average mobile behavior impacts your GPA in a negative way is greater than 3.00. The standard deviation of the question is 1.158 is given. And we assume that the question is uniformly distributed. Again, the null hypothesis say mean is less than or equal 3.00, and the alternative hypothesis say mean is greater than 3.00. And again, significant level is 0.1, C-score is minus 1.2816, and the test statistic is 0.4523. So we can conclude that the average mobile behavior significantly does not impact GPA in a negative way based on the sample data collected. The last one, we picked one question for the conditional probability. The average hours of using social media apps per day during the non-exam period is greater than 8 hours, where the average hour of using social media per day during the exam period is greater than 4. The event A is, say, average hours during non-exam period greater than 8. Event B said average hour during exam period greater than 4. So the conditional between event A and B is 0.6349. In conclusion, there is a probability of 63.49% of people using more than 8 hours on social media apps per day during non-exam period when people are using more than 4 hours on social media apps per day during the exam period. Thank you for listening our group project, and here is our member.